A nuclear reactor. So what exactly it is? See, it's a device where we use this fissionable energy or fission energy for constructive purposes. Okay, many uses are there. We'll look into that part later. Now, what is a nuclear reactor? See, this is basically a nuclear reactor. It's a cross section of a nuclear reactor. Now, there are many parts in this. See, there are two parts in this. One is the part where the fission actually occurs. The second part is the outer part where we take that energy, make useful energy out of it. So two parts. Let's start with the first one. That is what is there inside the core of the nuclear reactor. Okay, the core is where the actual fission occurs. So here the first thing is you have nuclear fuel. Okay, you guys can see the nuclear fuel. See, nuclear fuel, it's basically pellets. Like I told in the couple of videos before, you have the uranium oxide pellets. They're generally put in a long cylindrical tube and they're put inside this one. So that's a nuclear fuel. Mostly we use uranium or plutonium. Okay, so these are basically nuclear fuels. The next part, what you have is a moderator. Now, moderator, you already saw in the last video. Moderator, the main job of that is to slow down the fast moving neutron. Because fission is like an explosion. Imagine you have a cracker. Okay, you burst the cracker. Everywhere it just spreads around with so much of velocity. Fission is exactly like that. Correct? So as the neutrons explode like this, basically neutrons will fly away everywhere. Moderator slows it down. It's like calm down, you don't have to go too fast. So moderator's job is that. So generally we use heavy water, paraffin, deuterium, graphite. There are so many moderators. Okay, so from 50 km per second, the speed of the neutron, a moderator reduces to 2 to 2.2 km per second. Alright, then the third one is control rods. Control rods are very, very important because they control the safety in a nuclear reactor. Now, control rods are basically, they are materials which can absorb neutrons. Okay, so if you completely put it, nuclear reactor will shut down. If you completely open it, the nuclear reactor becomes an atom bomb. It's as simple as this. Okay, so how much ever output we want, we are going to open and close the control rods. That's why it's control rod. Generally, boron or cadmium, these are the two materials what we use to make control rods because they absorb the neutrons. Alright, the next one is a coolant. Now, coolant, this is the part or this particular, the job of coolant is, it takes the energy from the core of the nuclear reactor and gets to the outer circuit. Circuit in the sense, the outer part of the reactor. Okay, now coolant will circulate through the entire core of the this fission core and then takes out that heat, the energy comes to the outer part. Okay, so this is the part of the coolant. Now generally, see, we have something called as light water reactor, LWRs. Light water reactor, generally they use water or heavy water as the coolant. Okay, generally. But then most commonly used coolant is liquid sodium. Okay, so liquid sodium is made to run through the entire process here. So that's the job of the coolant. Coolant takes the heat from the core of the nuclear reactor, comes to the outer part, that heat exchanger part. Next part of that is shielding. Shielding is very, very important, don't you think so? See, what exactly happens is, the core of the reactor, it is surrounded by lead container, because lead absorbs all the radiations. Along with alpha, beta, gamma, there are different types of radioactive elements which will be going apart, correct? Lead absorbs everything. Outside that one, we are going to have concrete shielding, generally around 2 to 2.5 meters thick. 2 to 2.5 meters thick concrete shielding is required because gamma rays can penetrate, isn't it? That's why we use this shielding. This is for the protection. Fine. So this is the shielding part. Now what exactly happens? See, the coolant, It goes from the core of the nuclear reactor all the way to the heat exchanger, correct? Now in heat exchanger, it's heating up the water or whatever we have. Alright, and that one, it goes into, it's a superheated steam. So superheated steam will go and run the turbine, we generate electricity. All happy. This is how a nuclear reactor works. Again, the same process will continue. Fair enough? This is a working of a nuclear reactor. Very simple. Now that you know what it is and you know how it works, what are the uses of a nuclear reactor? Okay, the main use for a nuclear reactor is production of current or electricity. Okay, it's the main job of a nuclear reactor. But apart from that, there are so many other things. So many. Like see, nuclear reactors are used to create radioisotopes. And these radioisotopes are used in many places, like in medicine, in agriculture, in industries, and so many places. Alright? And these nuclear reactors, like I told, the power generation, they can produce a lot of power. Okay, they can produce a lot of power. That's the main job of a nuclear reactor. Okay, so now that you have understood what is a nuclear reactor consists of what, and what is the working and uses of a nuclear reactor. Fair enough? Now, in the next video, we'll discuss about the next type of nuclear reaction.